Alright guys, today's goal, understand how to represent functions as graphs. So we have inputs and outputs, and remember, a function for every input there is exactly one output, okay? So if we go to graph these, it's 1, 2, 2, 3, 4, 5. Okay? See the points here? Okay. So it says the horizontal axis of the graph is labeled as the input variable. The vertical axis is labeled as the output. So right here it says graph the function y equals 2x minus 1 with domain of 1, 2, 3, 4, 5. So what that means is you have to do this. Plug in the inputs, calculate the outputs. Six minus 1, 5. Eight minus 1, 7. 10 minus 1, 9. Okay, so now let's try to graph these. So remember, these are input, comma, output. X, comma, Y. So if we go to graph these, this maybe not quite big enough, so we have to change the scale here. So let's make these 2's. So if we graph 1, 1, it'd be approximately there, and then 2, 3, 3, 5, 4, 7, 5, 9. Now it is not a line. It just wants you to do those, okay? So don't connect the dots here. Alright, let's do some more examples. So let's just go over this example together. It says the table shows the average score S on the mathematics section of the Scholastic Aptitude Test in the United States from 97 to 2003. A function of time in T years since 1997 in table O corresponds with the year 0 corresponds with the year 1997, 1 corresponds with 1998, and so on. Graph the function. So you have 0, 5, 11, 1, 5, 12, 2, 5, 11. So see how here, now the key here, the reason I'm showing this is see this gap? Because here you can start 0, 2, 4, 6, 8. But here we have to have a gap. Because do you really need the 100, 200, 300 when the lowest is 511? No, so you have that big bridge that you have to include. And then the scales are there. So you have 0, 511, 1, 512, 2, 511, 3, 514, 4, 514, 516, 519. Okay? Alright. So let's look at another example. It says, write a rule for the function represented by the graph. Identify the domain and range of the function. Okay, so let's do domain first. Domain is 1, 2, 3, 4. Because look, oh, I missed one. Gotta have 0. So we have 0. We're looking at the x values. 0, 1, 2, 3, 4. Now let's look at the y values. We have 1, 2, 3, 4, 5. So those are the range. Alright, so we look at the rule. Well, where does this one start? It starts at 5 and goes down 1. And doesn't these go up by 1? So the rule is 5 minus x. Now here, I'm not sure, but this point not supposed to be there. So I'm not sure what happened. That's my fault, but it's not supposed to be there. So we're just looking at these 1, 2, 3, 4 points. Okay? Now, again, let's identify domain. We have 1, 2, 3, and 4. The range we have 10, 15, 20, 25. So I look. Do you see how these are increasing by 5 each time? So I know there's a 5. So I think if I multiplied this by 10, I'd get 10. But if I multiplied this by 10, I get 20. So what if I multiply 1 by 5? How much would I have to add? 5. So what I'm looking at is this. 5x plus 5. Y equals. Now let's test it. What's 5 times 2? 10. 15. Good. 3. 15 plus 5, 20. So there we go. There's our rule. Okay. Let's look at some more examples. Alright. It says the graph shows guitar sales in millions of dollars for a chain of music stores for the period 1999 to 2005. Identify the independent variable and the dependent variable. Describe how sales change over the period and how you would expect sales in 2006 compared to 2005. So let's look at this. So here's the thing. The independent variable is the years. It's always the X. The dependent is always the Y. So the dependent variable is the sales. The graph shows that the sales were increasing, trend continues. Sales would be greater in 2006 than in 2005. Because see how they're going up? So it says, based on the graph, example 4, is 1.4 million a reasonable prediction of the chain in 2006? Well, it looks like it goes up about 0.1 million every year. Because this is 0.4, there's 0.5, 0.6, and then it goes 2, 2, 1, 2. So right now it's at 1.3. So is it reasonable? Yes. Because it is increasing by 0.1 million per year according to the graph. Okay? We'll see you guys in class.